first video that looks at how we can use the identities we've learnt to solve equations. And this is very, very useful and can make complicated equations quite easy. So have a go at this one here and just look at the left-hand side and see if you can use your compound angle formulae to turn that into something different. Okay, so here's what you should remember, or look at your formula sheet to remember, and that's that cos of A times cos of B minus sine of A times sine of B is the same thing as the cosine of A plus B. So that means that on the left hand side we can rewrite all of that as cos of theta plus pi on 3, and that equals 0. Now we know exactly how to solve this equation. We can do it with a general solution, probably going to be the fastest way, and that's a pretty straightforward problem. This up here is impossible as it stands. So on the next slide, what I'm going to do is the general solution for that simple equation. Alright, so now I should have said at the start that what we're trying to do is to find the solutions for theta, and make theta between 0 and 2 pi. And that's going to give us practice at both the general solution and then substituting in different values of n to generate the solutions in this domain. Okay, so step 1 is to say, let's work out cos inverse of 0. Right, and there's my little cosine graph. So alpha is equal to pi on 2. Okay, next step is to take what's in here, theta plus pi on 3, and now we're going to apply the general solution formula to it. So for cosine, that's 2n pi, whoops, that should be an equal sign, just clean that up. So 2n pi plus or minus alpha, so plus or minus pi on 2. Right, so theta equals 2n pi plus or minus pi on 2 minus pi on 3. Now just remember, we don't want to combine those two bits because sometimes this first bit will be a plus and sometimes it'll be a minus. So that's my general solution. Unfortunately, I was asked for the solutions within this domain, so I now need to go ahead and substitute. So we'll start off with n equals 0, and we'll get theta is equal to 0. We'll do the minus first, so minus pi on 2 minus pi on 3, and that's going to be negative, so that's not a solution. Okay, so just writing it up again, this is my solution here, and now we're going to do the other half of n equals 0. So theta is equal to 0 plus pi on 2 minus pi on 3. Right, make those fractions of pi into something over 6 to get a common denominator. So that's 3 pi on 6 minus 2 pi on 6, which is pi on 6. So that's my first solution. Now let's look at what happens when we've got n equals 1. We've got theta equals 2 pi minus pi on 2 minus pi on 3, which gives me 2 pi, so we'll make that 12 pi on 6. Probably most of you don't need to do that, but we will anyway. Minus 3 pi on 6 minus 2 pi on 6. So that gives us 7 pi on 6. And we just check that we're in between our domain limits, which is theta between 0 and 2 pi. And that's looking good. So there's the first one, and there's the second. Now we'd better check the other side of the n equals 1 solution. I'm going to do that in here just to save another slide transition. So we get theta is equal to 2 pi, this is still n equals 1, plus pi on 2 minus pi on 3. We don't need to go any further to notice that this bit here is greater than 0, so this whole thing is greater than 2 pi, so it's not a solution. Alright, so we've got two solutions between 0 and 2 pi, pi on 6 and 7 pi on 6. Thanks for watching.